All right, so for problem number 6, it says express this number in scientific notation. So this is actually kind of easy because you can double check it on Desmos. But basically what I want to do, scientific notation has to look something like this. It has to be A, point B, dot, 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 like a number, decimal place, and then some more numbers if that's necessary for that, times 10 raised to some power p. So that's what it kind of looks like in general form. There's only one digit in front of the decimal. So in order for me to write this in scientific notation, I have the decimal point here. What I want to do is move it over 1, 2, 3, 4, 5. Because what I really want is 4.5. And that you got it. Sometimes I have to count these twice. If it's more than like 3 zeros or something, I have to count it twice. So I go 1. How many times did I move it? 1, 2, 3, 4, 5. So now that's times 10. Now over here will be 5. And there's some rules. So there's some rules. It will be positive 5 or negative 5. And every time I explain the rules, because there's only 2 rules, they do the opposite rule. Because sometimes you move it to the left, so it would be positive, let me rephrase that. Sometimes you move the decimal to the right, and that would be negative if it starts off as a decimal. But if you have a big number and you're writing it to scientific notation, you move the decimal to the left, and then that would be a positive value. But what happens when I tell kids that, they do the opposite. And so how do I double check this? Well, one, it starts off as a decimal, which means it's a very small number. That's how I kind of remind myself, and I do that. But even that rule confuses some kids. So then how can I double check this? Easy, I guess, right? If I want to make sure I get the right answer on the SAT, or more importantly on Mr. Adams' test on Friday, I'm going to guess that part. I know it's a 5. So I'm going to say 4.5 times 10, and I'm going to purposefully put the wrong one here. If I plug this in, that's not the right answer. So if I guess a positive value and I plug it in and it's not the right answer, then now I try the negative. 4.5 times 10 raised to the negative 5. Okay? Now when I plug that in, it's hard to say. So what I do is I actually plug it in. I'll say 0.1234. I think that's how it was. Yeah. Oh, you have to multiply this by 1. So if you do times 1, it'll spit out the scientific notation. Does that make sense? So it's not hard. We know we moved at 5 spaces. It's you got a 50-50 shot of guessing the positive or negative, but you don't have to guess. Just plug it in the calculator. It literally takes 10 seconds to try both ways, and then one of them will be correct. All right. So, anyways, that's the final answer. Now, what I will say, and you guys may not be used to writing it this way, but in mathematical notation, when you plug this in a calculator and how you could type it on the keyboard, the answer will look like this. Oops, this thing's being wonky. Another way to write this, and this just has to do with the calculator and how you can type it on a computer, it would look like this. And that's how the answer is listed in your Canvas assignment. Okay, those two things mean the same thing. Okay, this is what we call the caret symbol, and it's just saying, look, this number goes up in the top. It's superscript. That's all it's saying. Okay. All right, that's